Why can't I use the reverse of the chain rule? Because the top is not the derivative of the inside. Now come. Yeah, so it's not a reverse of the quotient rule or the chain rule or anything like that. We're stuck. Now, by the way, if that was 2 and that was an x, I could do it as a reverse of the chain rule, not the reverse of the quotient rule, reverse of the chain rule. If I had that as a 3, Ethan, it would just make it more yucky, and I can't do it as a reverse of the chain rule. So you're okay with when you can, when you can't? Now, I normally talk about the outside has to be the derivative of the inside, but this is not only a derivative of the inside, it's an inside bottom. An inside bottom, my goodness. An inside denominator. Because I'm going to do this here for a second. I could write that as x, 2x minus 1 to the power of minus a half. And what are we going to do? If it's a reverse of the chain rule, we increase that by 1, divide by the power, divide by the derivative of the inside, and the x's will not cancel, so therefore that method is not going. I will do it for a second. So that would be, let's go through and do it. So that integral would be, if I did that bracket, no, I don't even need that, x by 2x minus 1 to the half divided by a half, also divided by 2 plus c. Now, this will not cancel with that. So if I said differentiate this, would I get that? And the answer is no. And the reason is, I'm going to have to use u and v and give all that yucky stuff. So sometimes I remember being in a situation where I would go and do that and not realise I was wrong, especially when this said sine and cos. Okay, so let's go one now. So what do? Let u equals the inside.
Yep.
No thinking about it, the u dx is 2, we're going to use that in a second. So without thinking, I've got x, I'm going to leave that there. I've got square root of u, x. I've got that. And by the way, that looks pretty simple. I'm going to do this to you from experience. I'm going to write that as u to the minus a half. Ready? This bit's easy. So from this one here, I can just go dx equals what? Or can you do it?
1 or 2.
So the 2 and the dx can swap places.
Mm-hmm.
So you've got a du on 2. Or you could just write it's a half du. So that is just a half du. Yeah? Now the other bit, the x, over here. 2x minus 1 equals u, so 2x is u, you're right, plus 1, x is u plus 1 over 2, and I've got, now we've got to expand all those brackets out. So I'm going to write it what I call, I don't know, we still haven't integrated, have we? All we've done is
yeah, that's something. That's the question that I was asking earlier as well. So
I'm going to write that at the front. So that's 1 on 2 u to the minus a half outside of u plus 1 on 2. Yeah. So what can I do now? I'm going to do this. I'm going to write that as u on 2 plus a half. I split that into the 2, so I can go that by that, that by that. Mm-hmm. Then I'm ready to differentiate. So what have I got now? A half u times that, so that's a quarter. And you got u to the minus a half times u. What's that? Thanks for fixing that. If you can get it to work.
u to the half, right?
Yes. So u to the minus a half by u to the 1.
Just add them.
Yeah. This one, a half by a half is just a quarter. U to the minus a half. Because it's got no u there. U. Now you can do the i's. Now I want you to verbalise. What do I mean by i's?
I don't, it's just, I've always, I don't think
I'm going to push in.
Yeah.
Integration increases the power.
I think I've always done that. I've never even thought about going down anyway.
Yeah. So the power becomes U to the 3 on 2 on 3 on 2.
Yep.
And then equal integration divide, so you've got to not only increase the power and divide by the power, you've still got the quarter.
Yeah, that's interesting.
Is that it? It is, isn't it? Next one. Plus, and we got a quarter, and the minus a half becomes, hey, yeah, the minus a half becomes
Just
a half divided by the half plus C. Now the question's done other than tidying up fractions and substitute. So if I went all the way back up here, I'd go that 2, can you see the denominators there? I can go 2 into 4 goes 2.
Yeah, I didn't really do that.
I'm multiplying the fraction by the fraction on the bottom. So I could go 4 3s are 12 on 2. And 12 on 2 would be?
6.
Yeah. If I do it, I cancel the 2 with a 4. 2, 2 3s are 6. So everything that you knew in year 6 and year 7 about times in fractions suddenly is in a weirdo situation and it makes your brain up. See how long this explanation becomes if I take my time?
I think I just like flip it and then like take it in more steps.
Yeah. And that's okay. So you could have gone invert and multiply.
Yeah.
And that's okay. So if you prefer that, that's okay. So I've got 1/6 of U to the 3 on 2 plus this one. Do you see the half? What's a half of 4? Because they're both denominator.
Yeah, in my head I always just flip it up. So
You
I
would
have
have
to go
flipped.
2 on that, yeah.
So you would have gone from there and gone, okay,
Just-
I'm going to write that as
Just 2, yeah.
plus 2 on 1 plus C, and then you go cancel and you've got the half.
Mm-hmm.
So it doesn't matter which way you do it. U to the half plus C, substitute, and we got U, and what do we start with? 2x minus 1 to the 3 on 2 plus a half. You okay with that now?
Yeah.
Which I wouldn't write that way. I'd write that one as a square root plus C. Questions done? And that's pretty crazy. But at the same time. Now, if I redid it and I didn't put all the steps in, how much could I shortcut? What was my problem if I shortcutted too much? Yeah, couldn't stop it. So I wouldn't have written all that out.